Hi everybody, welcome back. We are up to lesson 83 today. I am going to date this lesson March 19th, 2020. And as we've talked about before, when it comes to the do now, if you'd like to shut this off for a minute and try the problem first and then check it against my answers, you're more than welcome to do that. So here's my explanation. Our do now problem asks us to find the length of the line segment with these two endpoints. So of course that would mean we need the distance formula. So the first thing I want to do is write that formula down. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. And now we're going to plug in all of our values from here, being extra careful with those negatives. And so you end up with the square root of 3 minus negative 4.7 squared plus negative 2.8 minus 6 squared. Now, either you can put this in the calculator just like this, or you can, of course, make that mental note that if you're going to say minus a negative number, that turns into a plus in between. Go ahead and pick up your calculator, throw all of that in at once if you would like, or do it one little piece at a time. If you want to do it one little piece at a time, you could do the x part first. This stuff in here, once I actually do that, would be 7.7 squared, and then do the y parentheses second, and that would be negative 8.8 squared. If you are putting this in the calculator, make sure that this negative 8.8 is in its own set of parentheses before you square it. It has to look just like this on your calculator screen. And then you go ahead and you throw that together. We end up with the square root of 136.73. 136, there we go, 0.73. And when we look at our calculator display there, we have 11.69316, etc. Going back up to the problem to see where we were supposed to round this to, it asked us for the nearest hundredth. So hundredth, of course, is 2 places past the decimal. So that means this is approximately equal to 11.69. So 11 and 69 hundredths, to say that properly. So today's lesson is all about finding a midpoint. A midpoint is the middle of a given line segment. So they have to give us 2 points, and we're trying to find the spot that's exactly halfway between those 2 points. So the formula for that is what you see here, and that is that midpoint will equal the sum of the x values divided by 2, comma, the sum of the y values divided by 2. Of all the formulas that we do in these couple of units on graphing, this is my favorite formula because it's the easiest one. You can really think of it just as an average, and you know how to do an average. Add 2 things up and divide by 2. That's all you have to do here. So you see this little note over here. Please make sure that you memorize this formula. That's really important. This is not on the formula sheet, the reference sheet at all. So sometimes, of course, they try to disguise these in other questions. Other times they just flat out ask for the midpoint between 2 points. So let's look at a couple of examples. First example here says that the endpoints of a diameter of a circle are 8, -2, and 6, 4, and we want the coordinates of the center of the circle. Now, you don't have to draw an actual graph on graph paper, but you could draw a picture of a circle and just kind of make that picture so that you can see it in your head. And of course, if they're telling us the endpoints of the diameter and we want the middle, they're asking us for the midpoint of that diameter. So we're going to use our new midpoint formula. Again, I've said this to you guys before, the more you write it down, the easier you'll find memorizing it to be. So x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And remember, we hit this earlier in the year as well. If it's a point, it has to be in parentheses. So make sure you do that. So now my simple plugging in here is going to be 8 plus 6 that I have to divide by 2. And then for the y values, I would have -2 plus 4 divided by 2. Make sure you actually do the adding together before you divide. So you have 14 divided by 2 and 2 divided by 2. This first problem works out really nicely for us. It would be the 0.7, 1. So there we go. That's your first problem using the midpoint formula. Next problem, done exactly the same way. If you think you want to try it yourself first, go ahead and do that, and then come back and check it with me when you're done. We've got 2 points again. They're asking us what are the coordinates of the midpoint of that line segment. So we're going to go ahead and we're going to plug into that midpoint formula again. You guys are just learning this formula for the first time. It really is to your advantage to write it down a couple of times. You know the way your elementary school teachers used to make you write your vocabulary or your spelling words 5 times each? Same idea. If you write your formula down a bunch of times when you're first learning it, you'll get it stuck in your brain a little bit easier. So we're going to go ahead and we're going to put our numbers right in where they belong here. So this is negative 5.3 plus negative 3.6, all divided by 2 for my x values. And then for my y values, I have negative 2.4 plus negative 6.3, all divided by 2. This is not something that people mix up usually because they don't know how to do the problem. If people are making mistakes here, it's usually because they were a little careless maybe, or they lost a negative sign, didn't put it in the calculator correctly. So watch out for those little nitpicky things that could end up costing you points here. So when you go ahead and you add that all up, put it right in the calculator, it actually works out not too bad. Calculator handles it for us. We should have negative 4.45. And then for the y value, you would negative 4.35. And that's your final answer for the second problem. So there you go. That's how you do basic problems with midpoint formula. Of course, now they're not always going to be basic problems. There's a few things that they could do that would change it up on you a little bit. And that's what we're going to look at next. So when you go ahead and turn to the back, there we go. Turn over to the back. Sometimes you'll see that they won't necessarily ask you for the midpoint. Instead, they tell you one endpoint and they tell you the midpoint, and you need to find the other endpoint. Now, you can do this by formula, but it gets really messy. You actually are better off with these problems just kind of looking for a pattern and then repeating that pattern like we've done with a few other things this year. So let me show you what I mean by that. When we take a look at problem number 3, it says the center of a circle has the coordinates 2, 7. One endpoint of the diameter has the coordinates negative 2, 5. And they want to know the coordinates of the other endpoint. So you could graph this on a piece of graph paper and look at it and count out the boxes. That would probably work. But chances are on a Regents exam or on a classroom test, we wouldn't give you a piece of graph paper for this. And it would be great if you had a way to do it just algebraically. That's actually the fastest way to do that. So let me show you. We have a circle. Again, we can just draw a quick sketch. And we know we have a diameter coming across. They tell us that the center of the circle is the point 2, 7, and they tell us that one endpoint is negative 2, 5. And we are supposed to find the other endpoint. We don't know that. So if we write these just down in a row, one endpoint is negative 2, 5, and the midpoint is 2, 7, and we're trying to find the other endpoint, what you can do is this. Look for a pattern. When you look at the y values here, 5 became a 7. How would that happen? Well, that would happen if you had added 2. So now add 2 again on the other side. 7 plus 2 would get you to 9. And then we can do the same thing with the x values. A little harder because there's a negative in there, so that's going to bug some of you a little bit. But just think about how you possibly could have gotten from negative 2 to positive 2. Well, you would have had to add 4. And so then you can add 4 again onto that midpoint, and 2 plus 4 would be 6. And that's actually your answer. The point 6, 9 is the answer to that problem. The reason why I like this method is because it's really just a matter of figuring out what you have to add or subtract and then repeating it on the other side. You can see right here in the work that you're 4 away in each direction from the midpoint for the x value, and you're 2 away in each direction for the y value. So this is the midpoint, and this has to be my missing endpoint. There is another way to do this problem, and that is by actually using a formula. And you could go ahead and you could plug in negative 2 plus x divided by 2 equals 2. and 5 plus y divided by 2 equals 7, and then solve each one. But honestly, that creates so much work, it really isn't worth it. So I'm going to recommend that you just look for a pattern and repeat it when they're giving you the midpoint and they want the other endpoint. So I'm going to show you one more problem like that here with number 4. The midpoint M of line segment AB is -2, 3. One midpoint is A, -5, -2. We want the coordinates of the other endpoint B. Okay, so we're going to write these in a row. The endpoints are A and B. The midpoint M goes in the middle. So that's the way we're going to write the points. M has coordinates -2, 3, and A has coordinates -5, -2. Now what you are trying to do here is figure out what you have to do to get from one to the other and then just repeat it on the other side. So to get from -5 all the way up to -2, you would have to add 3. You then would do that again starting at the -2. So -2 plus 3 would get me to a +1, and that's the first value there. That's my x value. Now I have to go do the same thing with the y's. So to get from -2 to 3, I would have to add 5. I'm going to have to do that on the other side. 3 plus 5 would get me to 8. So you figure out what you would have to do to get from the first endpoint to the middle, and then you do that same thing to the middle point in order to get the other endpoint. And so your final answer here is the point 1, 8. And that's really it. That's the whole lesson. What you have now at the bottom are a couple of quick little practice problems to go with it. So again, if you feel like you know what you're doing at this point, shut this off, take a little break, do the 3 problems left here, and then come back and see if you got them right. I'm going to go ahead and get to work right now. So we want the coordinates of the midpoint of a line segment if we're starting with the point -5, -6, and the other endpoints at 4, 4. So since we are looking for the midpoint, we're going to go back to using our formula here. Our formula for midpoint, x1 plus x2 divided by 2, and y1 plus y2 divided by 2. So when I go ahead and plug in here, I'm going to have -5 plus 4 divided by 2. And on the y values, I'll have -6 plus 4 divided by 2. When I plug that all in and round off, I end up with 1/2, comma, I think I lost a negative. I did. -1/2, comma, -1. And that's my final answer there for number 5. Same kind of practice, but this time with the other situation. They tell us here that the midpoint has coordinates -3, 4. The midpoint M of line segment AB has coordinates -3, 4. So this is my midpoint. If point A is the origin, we did this a couple of times last week. Remember, anytime you see the word origin, you can replace it with a 0, 0. We want to know what the coordinates of point B would have to be. So if they're giving us a midpoint, remember that's the one where you have to find the pattern. So A is the point 0, 0. The midpoint is the point -3, 4. And then in order to find the other endpoint, we're going to look for the pattern and repeat it. So to get from 0 to -3, you'd be subtracting 3. Subtract 3 again. Again, just be careful with negatives. -3 minus 3 should get you to -6. And then we have to do the same thing with the y's. To get from 0 to 4, you would be adding 4. So then you're going to add 4 again on the other side of it, and you have -6, 8. So that is your final answer for that question, -6, 8. And then I gave you one more, little bit more challenging problem down here at the bottom. We want to write the equation of the line that is the perpendicular bisector of this line segment. All right, so what does that mean? We talked about perpendicular bisectors way back when, in probably October or so. And a perpendicular bisector, of course, is a segment that hits another line or line segment that hits another segment right at the middle and cuts that other segment in half. So it would make sense that we'd talk about that again now, because the midpoint is what we would need. And we also know that perpendicular means that we have to have the negative reciprocal of the slope. So we have a couple of things going on here before we can find this equation. First thing, I will need the slope of my current line segment. So these 2 points, I'm going to find the slope. Going back to slope formula, y2 minus y1 over x2 minus x1. When I plug in here, that means I'm going to have -1 minus 3 on the top, and on the bottom I'll have 2 minus 10. That means I currently have -4 over -8. You have to simplify that. That means my current slope is 1/2. I want the perpendicular bisector. So the perpendicular slope would then have to be the negative reciprocal of that slope. So if the current slope is 1/2, the perpendicular slope is going to have to be -2. That's the first thing I have to find. Next thing I have to find is the midpoint of this segment. So that's our new work from today. Midpoint, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. I'm going to go ahead and plug in here. So I have 10 plus 2 divided by 2. And my y value, so I have 3 plus -1 divided by 2. That means I end up with 12 divided by 2 and 2 divided by 2 for a midpoint value of 6, 1. So far I've found myself the midpoint and I know what my slope has to be. Now, I'm being asked to write the equation of the line that is the perpendicular bisector. Well, it will be the bisector if it hits the midpoint. So that means this line that I'm trying to find the equation of, I can now create using the perpendicular slope and this midpoint. So now I have to write the equation. I know many of you prefer the y equals mx plus b here, even though really point slope form would probably be easier, but I'll do it your way because I know that's what's popular. Y equals mx plus b, and I'm going to plug in this point and this perpendicular slope in order to find the y-intercept here. So 1 is equal to -2 times 6 plus b, which means 1 is equal to -12 plus b, and then I have to add a 12 to both sides, having me end up with b equals 13. And that's my y-intercept. So using this new slope that I came up with, the perpendicular slope, and this y-intercept that I just found out to be the case, my final answer here will be y equals -2x plus 13. And that, ladies and gentlemen, is your final answer. That's definitely the most challenging of these questions. We have seen them ask things like that on the Regents before, so that definitely is something you have to go over again. And remember, you've got access to this video pretty much forever now. So if you want to take a break and come back and watch that again, you can always just rewind or, go back to that point and watch it again. All right, I hope you're all having a great day. I also hope that you saw my email this morning with a reminder about that first Castle Learning quiz that's due by tomorrow night. And that's it. So I will see you again soon. Have a great day. Bye-bye.